Next, let's move on to Beatrice for the text guided segmentation task.
Is my screen sharing?
Yes.
Okay, perfect. Um, Hi everyone, my name is Beatrice Chen, and I will be talking a little bit about the dataset formats of the text-guided segmentation task, and as well as the guidance on how to make successful submissions. Okay, wait, sorry. Okay, so just to introduce a little bit about the text prompts we are using for the text-guided segmentation task. So we want to introduce as much linguistic diversity to the text prompt as possible. So we used large language model, DeepSeek to be precisely, to synthesize multiple semantically equivalent descriptive sentences for each image case. And the generation process follows a template-based prompt structure, which I have already put here in the slides, that takes three key pieces of information, namely the object type, the anatomical site, and the imaging modality. So let's take the image at the lower left corner for an example. This is abdominal CT scan, and we want to segment out the liver region. So we would use liver as the object type, abdomen as the anatomical site, and CT as the imaging modality. So our query for the large language model would be liver in abdominal CT. And the LLM, which has already been configured beforehand for this specific task, would in return generate multiple variations of this sentence as shown in the slides. And we would then compile them into text prompts for the segmentation model training. And as probably you are aware of at this stage, that LM actually suffers from strong hallucinations. So to avoid that, we did manual sanity checks for every sentence generated. We identified four key major failure types, and we would manually go through each sentence generated by the LM to exclude any text prompt if any of those four failure type is detected. So the failures include not mentioning the target object, also refer as well as referring to another object or its subparts. So for example, if the object is small intestine, sometimes the LM would return in the sentence the LM returns would include like a subpart of small intestine, which is like the ileal segments or something similar. That is not considered acceptable. And also we would discard any prompts that's not describing the correct imaging modality or adding excessive context information. So for example, sometimes LLM would add extra information such as we're doing volumetric analysis for like the wall thickness assessments, which is something that we don't really want. So any of the four major failure, if they are detected in the text prompt, we will discard them. And as for how the data is stored, the image files actually shares a similar structure as the interactive segmentation challenge dataset, which June and a lot of previous presenters has already described. It's basically a set of NPZ files with a list of handles listed here on the left. But what's additional for the test-guided segmentation challenge is that we have an additional JSON file for the text prompt. And on the right-hand side, I'm showing a snapshot of what the JSON file looks like. So the top level keys refers to different data sets. And inside each data set, each class ID is mapped to a list of synonymous text prompts that are generated using the methods I talked about earlier. And inside each list, the first element will always be the class name. And at the end of the data set, there is also an instance label field. That one is used to determine the segmentation mask type. So it's a binary variable. One would denote that this is an instance mask, which is normally the case for tumor and lesion segmentations. And zero would just mean it's like semantic mask as normal. For the validation set, there is a slight difference. So instead of having an additional JSON file, we added this information to each NPZ file directly under an additional key called text prompt. And this field will contain a dictionary with each class having one sentence randomly sampled from the corresponding list of text prompts. And we would also maintain the instance label information here as well. So we do provide the sample codes here on the slides on how to access this information. And also on the lower right corner, you can see what once accessed, what the text prompt would actually looks like. So moving on to how your predictions and models will be evaluated. The eval script is actually linked on the challenge website. So please find some time to go through it to have a better idea of how your work will be assessed. But just for a high-level overview, we are expecting two inputs for the evaluation. One is your Docker file, and it has to follow the naming convention, which is your team name.tar.gz. And another input we are expecting is the list of segmentation results saved in MPZ format. And two things to specifically point out here. Please make sure that the MPZ files are saved with exactly the same name as the image input. And also for segmentation masks, they should be saved under the handle sex. Because here I'm including the line of code that we use to load your results. So if the file name or the segmentation handle doesn't match, nothing will be evaluated. And as for the metrics, as the Drepco previously also briefly talked about, we are evaluating the performance on both accuracy and efficiency. And we are implementing a rank then aggregate strategy to analysis the overall ranking. So as for the submission, it's quite similar to the interactive segmentation challenge. On the validation phase, we take submissions in two formats. So to get evaluated on your accuracy metrics, you can directly submit your generated NPZ prediction files in a zip file and upload it to the Codabench website. I will show a live demo right after this presentation, but it will be quite similar to what Suming just showed. And also, similarly, make sure that you change directory to the results folder before zipping, because we don't want any redundant folder structure in the zip file. And if you want to run the efficiency metrics, you can also submit it to us for your Docker files through email. And we kindly ask you to make one submission for every 10 days to avoid jams. And in order to send us the email, please follow the template of the subject line and what you are going to include. This information is listed out on our website, but just to point out again, please make sure the Docker follows the naming convention and they are less than 10 gigabytes, and also include a sanity check video. For that video, it's basically just to show us that your Docker can be running on the provided demo case successfully using the provided demo command, the Docker command. The command and demo cases are also accessible on the website. But just to make a quick note, for the Docker, please replace the team name variable here. I highlighted in blue with your actual team name, and do not change anything other than that. So the final testing submission phase is from May 15th to May 25th. And please note that we only accept one testing submission per team. And this is also going to be done through email, following a similar structure as the email submission for the validation. On the right-hand side, I am including a draft email template for your reference. So include the Docker download link, the sanity check video, and also the technical report. And next, I will try to do a live demo of the submission. This is the website for the test-guided 3D segmentation challenge. It's similar to the interactive one. You go to the My Submission page, and you click the icon for the zip file you already created. It will upload. And once it's done, we're running the evaluation on the Codabench backend. And you will see the status showing here. It will go through preparing, scoring, and then finished. And after it's finished, you can see your results here. And you can choose to add it to the leaderboard, which you can see. Everyone can see your results. on the other tab. And that's basically it from me.